Hello students, welcome to my channel Maths Insider. Congratulations for finishing the first chapter, Real Number. Today we will start Polynomial, one of the most important chapter in Mathematics class 10. By the end of this lesson you will going to learn about what a polynomial is, how to identify and why it is so important. What you will learn from this video is what is polynomials, what are the variables and constants, what is the degree of polynomials, and which algebraic expressions are polynomial and which are not. So let's begin with a simple question. So let's begin with a simple question. What is that? Have you ever seen an expression like this? So I'm going to write one expression whether you have seen it or not. So 2x plus 5, x square plus 3x plus 2, 4x to the power 3 minus 7x plus 1. So these expressions are nothing but we called this expression as polynomials. So these are polynomials. Now, but what exactly is a polynomial? That we will study in this particular video. So a polynomial is an algebraic expression. So it is an algebraic expression where or which is made up of number a variable, number b, some constants, number c, coefficients, and number 4, the whole number power of the variables. So these are the 4 ingredients which actually constitute the polynomial. So these are the main ingredients of the polynomials: the variable, constants, coefficients, and whole number power of the variable. So we will always keep this in mind when identifying a polynomial. Now all the above are connected either using addition or using the subtraction. So these are all combined. Now let's see how they are combined. Now let's understand each part. So consider the expression. So I am just taking an example, an expression 3 into x to the power 2 plus 5x minus 7. So here the letter x is the variable. So in this particular expression x is called the variable, and variable can take any value because its value can change. So it can take any value. It is independent. So value can change and it can take any value. First of all, this is called the variable. The number 3 and 5 which is associated with the variable, number 3 and 5 which are associated with this variable are called coefficients because they multiply with the variable. So with the variable they are multiplied. That's why they are called coefficients of the variable, 3 and 5 associated with this variable. And then we see there is a number called minus 7. This is called constant because there is no variable associated with it or is attached to this particular number. That is why this is called constant, no variable attached to it. Okay. So every polynomials consist of the variables, the coefficients, and some constants. So combination of this with this addition or the subtraction will give you the expression which is called the polynomial. Let's understand these terms making you makes you solve the polynomial easily. So now, what makes an expression a polynomial? So now, which particular expression we will say it is a polynomial? Let's learn an important rule. What is this rule? So for any expression to be a polynomial, the main rule is the powers of the variables. The powers of the variable must be a whole number. So the power of the variable, we can say power of the variable must be a whole number. Now what is a whole number? Whole numbers are the numbers which starts from 0, 1, 2, 3 and so on. That is a set of natural number plus the 0. These together constitute the whole number. Now let's see some examples. So x square plus 5x plus 6. In this particular expression, the power of the variable x is, they are 2 and 1. So 1 is 2, 1 is 1. So both these powers 2 and 1 belongs to the whole number. Hence we can say that this is a polynomial. So all algebraic expressions, all polynomial are algebraic expression, but all the algebraic expression are not polynomial. Now we'll take the example 2, 7. There is no variable attached to it. So can we still say this as a polynomial? The answer is yes. This is a polynomial. Let's clearly explain why this is a polynomial. A constant number is a polynomial because the 7 can be written as 7 into x to the power 0. So x to the power 0 will become 1 and 7 into 1 becomes 7. Hence, since the power of x is 0 and it belongs to the whole number, 0 is a part of whole number, so this expression 7 or constant is a polynomial. So is it clear? So we are following the rule of the power, that the power of any variable should lie within the whole number. Now let us see example 3. Root over x plus 5. We can write as root over x as x to the power half. So we can write the expression as x to the power half plus 5. And since the power of the variable x is not belongs to a whole number, is half, and which is not belongs to whole number, it is a fraction. So this particular expression is not a polynomial. It's clear. Now take an example, another example, example 4. 1 by x plus 3. We can rewrite this as the above expression as x to the power minus 1 plus 3. When you are moving the x from denominator to numerator, the power changes its sign. So since the power of x is minus 1, which is not a whole number and it's a negative number, therefore this expression is not a polynomial because the negative exponent of power or a power is not allowed in a polynomial. So this is not a polynomial. So 1 by x plus 3 is not a polynomial. So now the second important point is degree of a polynomial. How we'll find the degree of a polynomial? So now we have understood how we can identify the polynomial from a given expression, algebraic expression. Now second, once we have identified it, now we have to find the degree of a polynomial. Let's learn another concept, the degree of a polynomial. So the degree of a polynomial is the highest power of the variable. So whatever variable is associated with the expression, the highest power of that particular variable will be considered as the degree of that particular polynomial. Let's take a few examples to clarify this degree of a polynomial. Now example 1, take this expression 5x cubed plus 2x to the power 2 plus x plus 1. Now what is the highest power of this variable x? That is 3. So the degree of the polynomial will become 3 because the highest power of the variable x is 3. Okay, now take another example 2. Here we are expressing one algebraic expression as 7x square minus 9. So the highest power of the variable x is 2. So the degree of the polynomial will be considered as 2 because the highest power of the variable is 2. Take the third example. So in this example we are taking an expression 8x. So the highest power of the variable x here is 1. So we can say that the degree of the polynomial is 1. Now we will take another example, example 4. We will taking a constant value 15. So 15 can be written as 15 into x to the power 0. So there is no variable which is attached to this particular constant value. This is called a constant polynomial and its degree is said to be 0 degree. It is called a constant polynomial. So now we have understood how we derive the degree of a given polynomial. Now let's test your understanding. So we are taking some of the examples here, like 4x to the power 4 plus x minus 8. Now all exponents are whole number, so it is a polynomial. Here all the exponents of the power of the variable x is a whole number, so it is a polynomial and the degree is 4 because the highest power of the variable is 4. Now question number 2, 3 by x plus 2. Again this can be expressed as 3 into x to the power minus 1 plus 2. So x to the power minus 1 where the power is negative, it's not belongs to whole number, and so this is not a polynomial. Now question number 3, 5 root over x plus 1 or 5 x to the power half plus 1. Since it contains half as the power of the given variable x, which is a fraction and does not belongs to the whole number, so this is not a polynomial. So by having these examples we can able to identify quickly what are polynomials and what are not polynomials, and if it is a polynomial, what is the degree of the polynomial. Let's quickly revise today's lesson. So a polynomial is an algebraic expression with number a variable, so it will constitute a variable. It will have the coefficients attached to the variable. It can have the constants and the whole number exponent or the power of the variables. So combining this we will get a polynomial. And remember these two golden rule. Rule number one. What are the two golden rules? Number one, exponent must be whole number. Only then it will become a polynomial. Rule number two, the degree is the highest power of the or highest exponent of the given variable in the expression. So combining these two rules, we can able to find the polynomial very easily. We can identify it very easily, and that will help you to solve almost every questions in this chapter. This is fundamental. We need to follow this rule, keep this rule in our mind. Here is your assignment, which will help to test your understandability. So identify whether each of the expression is polynomial, and you can able to find its degree if it is. So question number 1, 6x cube minus 2x plus 5, 4 by x plus 7, 9 and root over x plus 4, and question number 5, 2x to the power 5 minus 3 x to the power 2 plus 8. So you can write your answer in the comment section, and I will try to check them in the next lesson. So in the next video we will going to learn about the types of polynomials. Thank you.